Okay, Assalamualaikum. Are you still here?
Waalaikumsalam, sir.
Lagi
Yes.
sekali, you know what? If this thing happen one more time, if it is, my house, the problem with my house, the electricity, if there is a thunderstorm a little bit, dia dah potong, tendang. So if this happen a few times, we will have a class tonight after Tarawih. Okay, all right. So let's continue. So last time we were looking at benda tadi tu. Okay, here we were here. So you have a system of linear equations of two equations, and then you find the solution. That solution will be critical point: x0, y0, and then z0. So what you do there? Yeah. Yes.
Your screen doesn't show here.
Okay. Saya tak share. Okay, again, thank you. I will share screen. Okay.
Thank you, sir.
Okay, thank you. So what the second part would be getting the second partial derivative. So that will be our second part. Okay, number 2, you will find the second partial derivative. Why do we do that? Because you have to determine, okay? You have to determine some function, and that function is consisting of fxx, fyy, and so on. So I define the function d, and it's a function of x and y. That is equal to fxx multiplied by fyy. Now, everything here are functions of x and y. Okay, fxx, a function of x and y. Fyy is a function of x and y. And then we have to subtract fxy, which is also a function of x and y, everything squared. So that is called D. I think D maybe stand for, you have the difference here. You have the multiplication of fxx, fyy, and then you have to subtract fxy squared. So maybe that's why they call it D. And short form, sometimes, it's quite difficult to write. This is too long. So short form, you just write D equal to fxx, fyy, minus fxy squared. Okay? But we know this is the function. Okay, we know that's a function. And it depends on x and y. So what you need here is, of course, in order to get the D, we need fxx, fyy, fxy. After you got this, you put into that D. Then you got D. Okay? So you put into the D, you got D. What we need is we have to evaluate. Okay, you have to evaluate D, xy. I'm going to write the long version because you want to specify that it is evaluated at the critical point. You have to evaluate dxy at the critical point. So here I don't need the value of z. I just put x0, y0. All right. So when you do that, what you have, we'll have d x0, y0. So that will be a value, okay? And that is obtained by taking the second partial derivative, evaluate at all these critical points. At the critical point, x0, y0, minus fxy at x0, y0. Everything squared. Okay. All right. But another way to do this, you don't have to evaluate. All right. You don't have to evaluate the second partial. we just evaluate D, okay? Because you already got D by taking the difference in the terms, so you got already a D, all right? So you can do it directly to D, or you can also do it through the partial derivatives, through the second partial. But doing this one is easier because you do it directly from here. So what I mean here is that when you got the terms, put in the terms, fxx, fyy minus fxy. So when you put in together, you simplify. Okay, so you simplify, then I just got D. If we don't simplify, then equivalently that we are going to do it on what we have on the right hand side. Okay, but normally we do it just directly after we simplify the D. Okay, all right. So you got the value of D and evaluated at x0, y0. So that would be what the value would be. What are the possibilities of the value? What are the categories of value? You got D, it's a number. So normally when you have a number, generally categories are what? Normally we categorize into what? Paham tak paham saya cakap?
Negative.
You categorize into negative or positive or zero. Okay, so that would be our third step. So number 3, if the D that we evaluate at the x0, y0 is positive. Okay, now when this is positive, then you may have a maximum and minimum. But that is not the condition. That is only part of the condition. Okay, if D is bigger than 0 at x0, y0, and we have to also look at the value of fxx at x0, y0. If the value of fxx at the x0, y0 is also positive, and fyy at the critical point is positive, then only we can conclude. Then we say that the function has a relative, or sometimes you don't have to say relative, have a minimum at x0, y0, and of course you put in that 0. All right, so that is a minimum. So you see, minimum, you have to have, all right, 2 conditions. D is only the first condition. All right, D is condition number 1. If D is positive, then you can have a maximum or minimum. You need to look at what? I need to look at fxx and fyy. If both of them are positive, then only we can conclude the function has a minimum at that point. Okay, so this is 3A. Now 3B, for a maximum, if the value of the D at x0, y0 is positive, and we need to look at fxx and fyy. And fxx at that point is negative. Okay, and also fyy at the critical point is also negative. Then what? Okay, then we conclude that the function z has a relative maximum at x0, y0, z0. So here again, the condition, the first one would be D bigger than 0. And then if fxx is negative, fyy is negative at the critical point, then we have a maximum. Okay. So, are you done? Are you done? Are you done writing it or not yet?
Not yet.
Okay. Take your time.
Done, sir.
Okay, so now the other possibility of the D would be equal to 0 or negative. So we go to negative first. So C, all right, for the possible or situation, you have the value of the D at x0, y0 is negative. Okay, now if it is negative, then it is not a maximum, it is not a minimum. Z has a saddle point. Okay, saddle point at x0, y0 at the critical point. Now, what is a saddle point? The saddle point, the concept is similar to what you have earlier. Okay, the function is not a maximum, it's not a minimum. So for this three-dimensional function, a good picture, of the saddle point. You go to 14.4. 14.4, the picture given in figure 14.11. You see here, from one side, if you're coming from the x-axis, from the x perspective, you have a maximum. The function is going up and then going down. But from the y, all right, from the y-axis, the y perspective, it is a minimum. So that's why you call it a saddle point. So it's like a saddle, like a horse saddle. If you look at the horse saddle, you watch cowboy movie tonight. Watch The Good, the Bad, and the Ugly. Ataupun watch lah. All. So you see the saddle of the horse. You see from the back to the front, it is going down. And then from the left to right, it's going up. So it's like that. So a good picture is figure 4.11. And then the possibility number 4, you have D that you evaluate at the x0, y0 is equal to 0. So here we cannot say anything. So no conclusion. Now, the first two are the most important thing. So like what we were doing earlier, the one that is the maximum or minimum, these two are most important because you need to know, whether you have a maximum or minimum. Now, if you have D is less than 0 or D equals to 0, we stop here. Okay, you don't have to determine whether fxx, fyy, whatever the value is. Okay, so if D is less than 0 or D is equal to 0, we stop where we are. So this is not that important. We just know, okay, that if we have these things, you have a saddle point. Or if D is equal to 0, we cannot conclude anything. All right? Okay, so that is the test. So the test, actually just like the one that you have earlier, it is made up of 2 stages. One is to get the critical point, all right? But here, to get the critical point is a little bit more work, because you have a system of equations. And then you test by the second partial. So that is the test. All right. So in order to get a better understanding, we do a few examples. So let us start with example number 1. you go to 14.4, you look at example number 1. Now, example number 1 in the book. So you can look at the book. I will just work it out. And we work out according to the test, the method of the test. So if you look at example 1, the function, okay, you give it a function, y equal to x squared plus y squared plus blah, blah. So what you need first, all right, given the function, you want to find a maximum or minimum. So first step, okay, I just write the step, all right. We know the function. I hope everybody look at the example 1. So first thing is you need to find the critical point. Okay, find the critical points, or in case there are more than one critical point, where fx equal to 0, fy equal 0. So take the first partial. We need fx. Right? Now, what is fx? You have the function there. What is the function? If you take the derivative with respect to x, what do we get?
2x minus 2.
That is very simple because every terms are just additive, right? So you got 2x minus 2. And then you have fy equal to take derivative with respect to y. There is only one term in y, that is y squared. So you got 2y. So these are the first partial, fx, fy. So now what you do, you set them equal to 0. All right. So for critical point, where you need those to be 0, so what we have is 2x minus 2 equals 0. Call it number 1. And then you have 2y equal 0. Call it number 2. So here you have a system of equation. And the system is very simple. Okay. So the system is very simple. You can do it directly from 1 and 2. You get the variables, the value of x and y. So here from number 1, I get x. So what is x? X equal to 2 over 2. That is equal to 1. And then from number 2, I can get the value of y. 2y equal to 0. Y equal 0. So I have what? I have x0, y0. And of course, you can find the value of z0 that is equal to 1, 0. So to get the value of z0, what do we do? How to get that? What do we do? How do you find it? Substitute into what? Into fx ke, fy ke, apa benda?
Into Z, sir.
Substitute into z. Okay, the original function. Okay, substitute into z, you get z0. And if you look at the book, they already give find it for us. Apa value dah? 0. Okay, so 1, 0, 0. So the critical point is 1, 0, 0. Okay, so that is first part. We find critical point. You set them to as a system of equations. You solve for the x and y. You get the critical point. All right. Okay. Now, secondly, we take the second partial. So you know that d is equal to fxx, fyy minus fxy squared. So what you do here, you need what? I need fxx, fyy. You don't have to write. When you do this problem, you don't have to write fyy, this thing. I just want to write it so that we know the step. You just find it, okay? So you need this. So what do I get? fxx, derivative of fx with respect to x, we get 2. And then fyy equal to what? Fyy equal to 2. And then fxy equal 0. So we know that d, okay, now you have to write the d. So the more you write, the better we remember. So d is fxx, fyy minus fxy squared. And that is equal to, put in the functions. So I got 2 times 2 minus 0 squared. That is 0. So that is equal to 4. Now, in this example, number 1 is very simple. Why? Because everything is a constant. Okay, everything is a constant. That is equal to 4. The d fxx equal to 2 and things like that. But we need to show, okay? We need to show at the critical point x0, y0, what is the value of d, even though it is straightforward. So at 1, 0, okay, what is d? D is equal to 4, and that is bigger than 0. So that's why I said the first part, when you evaluate the d at x0, y0, you evaluate directly. That means we already solved. Okay, we already solved the difference between fxx and fyxy. We already simplified. So you got the simplified version. This is the one. So you evaluate directly. If you don't, then you have to do it by fxx, fyy minus fxy squared. But it's better, it's better to evaluate directly like this. So you got d bigger than 0. So d bigger than 0, we know, okay? You may have a maximum and you may have a minimum. It will not be a saddle point. So in that case, we can proceed. Look at the value of fxx, all right? And fxx at the value or at 1, 0. So again here, you have to look at 1, 0. What is fxx? It's a constant, right? So it's equal to 2. So fxx equal to 2, and that is bigger than 0. All right? And then fyy at 1, 0 is also a constant that is equal to 2, and that is bigger than 0. So you see here, you have the full conditions. You have d positive, fxx is positive, fyy also positive. So what is our conclusion regarding the function? Maximum ke minimum?
That has a relative
You have a relative
point, sir.
minimum lah kan? You have a relative minimum. So the function z has a relative minimum. Okay, minimum at 1, 0, 0. Okay, all right. So look at example number 2. Okay, in the second example, where you have a saddle point, you will see that you put in the critical point, you find the critical point, and then they compute the value of d. The value of d is negative, so that's it. You don't have to proceed any further. That will be a saddle point. So example number 2, I would like you to read later. Okay, example 2, read it and look at the diagram because it's a saddle point. All right. Now I go on to example number 3. Example number 3. Okay, example number 3, I'll give another function. Before you move on to the example number 3 in the book, we look at another example number 3. That this example I'll give the function because we want to see a different form, okay? Different form of the system. So look at z equal to f of xy equal to 2x squared . 2x squared plus 10xy. Okay, that is a 10, right? That's a 10. Plus 10x squared, no, plus 10xy plus 3y squared minus 15x plus 7y. Okay. So what I want you to do, okay, I want you to finish up the first step, all right? Find the critical point. Okay, go ahead, do it now. I give you 5 minutes because this thing here may not be very difficult, but it may take some time for us to get the solution. So you find the critical point, set fx equal to 0, fy equal to 0. You have a system of 2 equations. Find the solution. That solution will be the critical point. Okay, do it now. Kan, mana pergi yang kat sini ni? Bukan selalu ada sini. Dia tutup. That thing, you know, where I can see the list of students. Oh, ni ada. Tadi tak ada sekejap. Okay, you got the fx, fy? And then get the point, all right? The first person who get the solution, let me know. Okay, you got the value? X and Y? Anybody who got, let us know. What, Najiha? What is the value of X and Y?
Sir,
Yeah. Kenapa? Saya tak share screen ke?
yeah,
Maksud,
not your screen.
okay. Tadi dia terputus sekejap. Alright. So what is the value of X and Y? What is it? You have a system of linear equation. Is that right? So if you get the partial derivative, what do we have? We have fx. What is fx? Fx equal to 4x plus 10y minus 15. Okay, so for to find critical point, that means fx equal to 0, fy equal to 0. And then what is fy? What is fy? Fy is take the derivative of the function with respect to y. I got 10x plus 6y plus 7. Okay, everybody got that? Now, anybody who got it wrong? Tell me. Anybody who got it wrong for this partial derivative? Okay, anybody got it wrong? Let me know. I want to see.
Me, sir, me.
Okay, what is the error? Where is the error so that I can point out the reason? Okay,
I put 3y square into the function
you see, so 3y squared here.
on fx.
But this y is a constant, okay, and it doesn't multiply with any x. So when you take derivative, that will be equal to 0. Okay, so the only terms that you take for derivative of with respect to x is 2x squared, which is 4x, and then you have 10xy, you got 10y. Okay, the 10y you got right. Siapa nama tu? 10y. Okay, so kita jumpa balik. So sekarang ni saya kena share screen semula lah. Alright. So that is the first partial. Now you set that to 0. Okay, set that to 0. I have 4x plus 10y minus 15 equal to 0. Call it number 1. And then I have 10x plus 6y plus 7 equal to 0. That is number 2. So you solve. This is a system of linear equation. Now, anybody got this correct? So if you got that correct, okay, what is the value of x and y that we determine, for the solution? Anybody? Okay, takkan semua salah. Ada yang betul tak?
X, I got negative 0.475.
X equal to negative
0.475.
Okay, x is equal to negative 0.475. Okay, what about y?
1.69.
1.69. Okay, anybody else get the same thing or you get a different solution?
Different, sir.
What did you get? Okay, what is
For x, it's 9.6.
x is 9.6. Well,
Y is negative 2.34.
Okay, so now you have 2. So let me check. Okay, let us check. Anybody else who get a different point?
Sir,
Yeah. Okay, what did you get?
Sir? Sir? Sir, you are muted. Sir, you are muted.
Okay. Okay, there you go. All right, you hear me? There you go. Okay, can you hear me now?
sir, your internet connection is not stable as well.
Yeah, I know.
Yes,
Because
yes.
of the weather is not very good. Okay. Can you hear me now? Boleh? Boleh dengar?
Yes.
Okay, good.
Yes, sir, clear now.
Okay, good. So now check again. I have 2.34. So can we verify whether I was wrong or she was correct?
Sir, actually, I was wrong. It should be positive 2.34.
Should be positive, right? Yeah. So
Yes,
I
and X should be
so you got x
And x
equal
also
to
negative
2.34. So y is equal to 2.34. Okay, so if that is the thing, then what is the value of x?
Sir,
Yeah. So y equal to, yeah. What you have to say? Go ahead.
I got a different x from those two.
Okay, what do you get?
I got negative 2.11.
And then
Negative
and then what
2.11.
is y? Negative 2.11. And then y, what do you get for y?
Y is 2.34.
Okay, I think you will be the correct one. So y is 2.34. Okay, so let me check. Y equal to 2.34, and then we put into the x. That will be equal to negative 10, 2.34 plus 15. Everything divided by 4. Let me see. So 10 multiplied by 2.
Actually, sir, negative 2.1 is more accurate than negative 2.11.
Yeah. 2.31. Okay, 2.34. I got 2.11, 2.1. So it's okay. If you have, 2.3, that's close. I think that will depend on maybe how you take the decimal point. So you got x equal to negative 2.1. Okay, 2.11. So I also get this one. And if you got close, that is okay. So now this is the thing that I said. To find the solution to the system sometimes is also not that simple. Okay, that will depend on the first partial derivative. So we got that. So you got the critical point. So now you find the value of z. So okay, I write down here x0, y0, z0. All right, that is equal to negative 2.11, 2.34, and then you get z0. Okay, so z0, to get it, you substitute into z. Substitute this x and y into z. Okay, you get it. So now, actually, we don't need that. We can come back to that later on. So what we do next is you take the second partial. Now you look at the second partials, what do we have? So number 2, you find fxx, and that is equal to what? Equal to 4. And then you take the second partial fyy. What do we get? You get 6. And then take the cross partial fxy. We have what? We have 0. So d, okay, is equal to fxx, fyy minus fxy squared. Yeah. Yes.
Isn't fxy 10?
fxy. fxy. Yeah, you're right. fxy is not 0, it's 10. Okay, thank you. So fyxy is 10, fyx is 10. Okay, so it's 10, not 0. Thank you. So
Isn't fxy 10?
fxx, Papa? fxx is 4. fyy is 6. Betul tak? And then fxy, 10. Okay. What is your fxx? Betul tak betul? Is it right? So you have fx equal to this thing here. So fxx is 4. Fyy is 6. Fxy 10. Is that right? So you put into the D, we'll get D is equal to, put in the values of the second partials. That will be equal to 4 times 6 minus 10 squared. All right. Oh, here we still have a saddle point. Okay, so here 24 minus 100, that's a negative. So that is equal to, just give me the value. So this example is not a good example. 24 minus 100. But it is good exercise to determine the critical point. So that is a negative, you have a saddle point. Okay, saddle point at that point. At negative 2.11, 2.34 at the critical point. Okay, x0, y0, z0. So equal to whatever you get. Now we still have a saddle point. Of course, the conclusion is not very good, but we did the system, okay, to determine the critical point. Okay, so what this example is telling us is that sometimes, more work is done on the finding of the critical point. Okay, all right. So let's look at another example. Okay, this one you have a proper maximum minimum.
Answer.
Yeah.
The answer is negative 76, right? Because 24 minus with
Yeah, negative 76.
100.
Yeah, you're right. So that is negative 76. Okay, 24 minus 100, negative 76. So that is less than 0. So you have a saddle point at the critical point. Okay, all right. Okay, anything else? So clear, clear this example. So now we move to example number 3 in the book. Okay, example number 3 in the book, you will see the critical point. For the critical point, the system of the function is more complicated. But that's not something that we cannot do, okay? Something that we do, but require us a little bit more remembering of the formula. So let's go through the example number 3 in the book. Because I have only about 10 more minutes, so we just go through the derivative. So here is example 3 in the book. So now becomes example 4. So you have the function, and then, okay, for number 1, I have what? I have fx equal to 3x squared plus 6y plus 24, and then fy equal to 2y plus 6x. So you set that to 0. Okay, set that to 0. This is what I will do. I will start from here, 3x squared plus 6y plus 24 equals 0. So that is our equation number 1. And then fy, I got 2y plus 6x equal to 0. That is our number 2. Okay, so here you'll see function. Both variables appear in each of them. And then the other one is a quadratic, or x is to the power of 2. So how do we do this? Where do we start? So you have to start with something that you can write x in terms of y. Okay, so that you can solve one of the variable. So you can start with what? You can start with 1, that will be difficult because you got x squared. So you start with number 2. So from number 2, what do I get? I get 2y equal to negative 6x, then y equal to negative 3x. So I got y in terms of x. And then you substitute into number 1. Okay, substitute y into number 1. So now what we will have will be equal to 3x squared plus 6 times y, which is negative 3x. Okay, plus 24 equal 0. So now everything is in x. We can find the solution for x. So I have 3x squared minus 18x plus 24 equal 0. So here, this is where you have to remember the roots formula. X equal to negative b plus minus square root, whatever, divided by benda to 4ac. You know? So check this again. I also cannot remember. So maybe I'm correct, maybe I'm wrong. But that is the formula. So you go and check again, you know, chapter 2 ke chapter 1. Okay? So cut the story short, we find the solution. You know, the book factor out the 3, so you can only do that also. Okay, you can factor the 3 out. So what you will get, forming this thing here, so this one, homework. Okay, find the value of the x, find the roots to the function. So we know x equal to 2, and then x equal to 4. Okay, so show it by getting that thing. Or if you remember the shortcut formula, but not using calculator. Okay, right away getting calculator, we don't know what we are doing. Okay, we know what it is, but we don't know how we get it. Okay, but how you get it is also important. So when x equal to 2 and x equal to 4, so that will indicate that you have 2 critical points. So for each of these x, you find the corresponding y and the corresponding z. So first one, you do the x equal to 2. So let us do that. So when x equal to 2, what is y? So when x equal to 2, y is equal to negative 3 times 2, that is equal to negative 6. So you got the value of y, which is negative 6 at x equal to 2. And then, given here, you find the value of z, all right? So if you look at the book, you substitute into z, work it out, I got z equal to how much? 20. So our first critical point is call it x0, y0, z0, that is equal to 2, negative 6, 20. So that is our first critical point. Now you do that also for x equal to 4. All right, when x equal to 4, what is y? Y equal to negative 3 times 4, that is equal to negative 12. And then you find the value of z. So I got a second critical point, call it x1, z1, that is equal to 4, negative 12. And if you look at the book, that will be what? 16. So there are 2 critical points. Okay, so now you have to do the test twice, one for each of these. That means to get the value of the second partials. Okay, all right. So now you do the second part of the test. You find fxx. Now, what is fxx? Take derivative of fx with respect to x, I get 6x. Take derivative of fy with respect to y, fyy, we get what? We get 2. And then take the cross partial fxy, we got 6. And then put into the d. D is equal to fxx, fyy, minus fxy squared. Saya tak mute tu, okay. Okay. So that is equal to what? That's equal to 6x multiplied by 2 minus 6 squared. So that is equal to 12x minus 36. So here, you'll see here, I got an x in there. So now, what do? We do what we always do, substitute. So first, you evaluate d at the first critical point. At x0, y0, z0, which is equal to 2, negative 6, 20. All right, so at that point, what is the value of d? So d is equal to, you have 12x. So what you do, you substitute. These are the values of x, the value of y, the value of z. Okay, whatever happened in the d, or whatever that you have in the d, you substitute with the particular value of the variable. So here you got 12x minus 36. So that means you got 12 times 2 minus 36. That is equal to negative 12. So negative 12 is less than 0. The function has a saddle point. Okay, has a saddle point, so we stop there. At 2, negative 6, 20. All right, so now we do it at the other point. So at the other point is 4, negative 12. So, at the other point is 4, negative 12, and then 16. Okay, so I want you to find the d. Of course, in the book it's already given. Okay, but in the book it's very, it's quite, the book, you read it as it is. But here, we do it step by step. So now I want you to do for the second point. So you repeat the test to get the value of d. So at the second point, x equal to 4, y equal to negative 12, 16. Okay, now get the d. Okay, what is the value of d?
12.
12, everybody got 12. So you have what? I have d is equal to 2x minus 16. Substitute the value 4. So you got 2x. Okay. Berapa tadi? 12x. I'm sorry, 12x. Not 2. 12x. So 12 multiplied by 4 minus fxy, which is 6 squared. All right. So you got 12. And that 12 is bigger than 0. So bigger than 0, we may have a maximum, you may have a minimum. We have to look at fxx. So at that point, for negative 12, fxx, put comma there, fxx equal to what? Fxx equal to 6x, and you multiply by 4, so I got 24. And that is positive. Okay? And then fyy is a constant. Fyy, we got equal to 2. And of course, that is bigger than 0. So, what is our conclusion? You have a maximum or you have a minimum?
Minimum.
Minimum lah. Okay. You have this thing here is positive. That thing here is positive. D is positive, so minimum. So conclude. So that is example number 3. Okay. All right. Now I give you another one, because here I want to emphasize on we have to substitute the value of the critical point of each of the variable into the D, into fxx, into fyy, if, okay, if those variables appear in the terms. Okay, I'll give you another example. So this example has nothing to do with a function. Okay, this is just imaginary to show that how we do the substitution. So example, let's say I have fxx equal to 4x squared plus y. And then I have fyy negative 2y cubed plus 10x. Okay, and then fxy equal to 4 fxy equal to tengok di lain ni ya. So jangan percaya ni salah ni. Okay, ini semua salah sebab fxy fyx tak sama. So probably I put a 10 here lah. Put 10 here. So I got 4xy equal 10. Okay. So now what is D? D is 4x squared plus 10y multiplied by negative 2y cubed plus 10x minus 10 squared. See here you got xy everywhere. Okay. So now what you do, at a particular critical point, suppose I have a critical point at 5, 10, 20, 30. So suppose that is our critical point. So what do we do? At that critical point, you substitute the value of the x and y into the fxx, into fyy, into the d to determine whether you have the necessary condition or not. Okay. So now first thing you do is you put into d. So d is equal to what? So d is equal to, now you have a big thing. So you got 4, 5 squared plus 10 multiplied by 10, everything. And then I have negative 2, y cubed, 10 cubed plus 10x multiplied by 5, thing, minus 100. So you got that thing. Okay, so what I'm trying to tell you here is that don't worry about the D. How big is the D? How many variables are there? You put in the value of the X, put in the value of the Y for the critical point into the D to determine the value. Okay, all right. Now, similarly for X, fxx. So fxx at that point, what do? We substitute. So what do I get? I get 4, 5 squared plus 10 times 10. So you put into this. So you get the value fxx. And then for fyy, equal to what? Equal to negative 2 y cubed. That means 10 cubed plus 10 x, which is 5. So that's it. So you get the value of fxx, value of fyy, value of d. So you need to substitute. Okay, you need to substitute the value of the x and y at the critical point into the relevant terms. Number 1, d. Number 2, fxx. Number 3, fyy. If it is a constant, that is the most straightforward. But sometimes it may not be. Okay, so we have to do the substitution. Okay, all right. Any question? Any comment? Anything? Yes. Yeah.
I have a question.
Okay.
If at D we got a negative, then it is saddle point. So does that mean that we don't need to evaluate fxx and fyy?
No, you don't. Okay, there is not necessary because the first condition, which is D, okay, if the first condition, which is D, is not met, then you don't have to proceed. So first condition is the D, right? So if the D is less than 0, so you stop there. You don't need the fxx, fyy, right? You don't need that because that is only So it doesn't matter, okay? If D is negative, it doesn't matter whether fxx is positive, fyy is positive, it doesn't matter. You cannot say this is a minimum. Why? Because D is negative, okay? So that's why we stop there, okay? You don't need to get into the computation of the fxx, fyy. All right, okay. All right. Even same thing, if you got D equal to 0, then no conclusion, you also stop there. You don't need to find the fxx, fyy at that point. Yeah? Okay. All right. Any other things?
Okay, sir.
Okay. Okay. So you do the question over this, from tomorrow until Sunday, we have 4 days. So you do as many as you can, and then make sure we'll be able to apply the test. Next week, we are going to look at application. So in the application, we're going to apply this test to determine maximum and minimum. Okay, all right. So I will see you again. Have a nice weekend. Have a nice day. Have a nice breaking fast. I will see you again next week. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
Waalaikumsalam.
Thank you, sir.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Semua lembik
Assalamualaikum, sir.
ngantuk puasa penat ke? Semua lembik bunyi. Ini baru pukul 3:30. Okay.